Have you ever wondered why the world can agree on how to measure a fever or the freezing point of water? And what happens to molecules when we reach the theoretical limit of cold? It seems like a simple question, but the answer takes us on a wild ride through human history, global science, and the very fabric of the universe itself. One minute, you're checking your phone to see if you need a jacket, and the next, you're grappling with the fundamental laws of physics. So, buckle up, because we're about to decode the three big temperature languages that run our world. The Fahrenheit scale, that trusty system you see on weather reports across the United States, was actually designed around the human experience. Back in the early 18th century, a physicist named Daniel Fahrenheit was trying to create a reliable and repeatable thermometer, according to the National Institute of Standards and Technology. He set his scale's 0 point using a chilly brine of ice, water, and salt, the coldest temperature he could consistently create in his lab. For his other key marker, he reportedly used the temperature of the human body, setting it close to 100 degrees. This approach was all about us, about how the world asterisk feels. Asterisk, it's no wonder Fahrenheit can feel so intuitive for day-to-day life. Think of it as a scale of 0 to 100 for human comfort. When you hear it's 0 degrees Fahrenheit outside, you know it's brutally cold. When it hits 100 degrees Fahrenheit, you know it's blazing hot. It's a gut-feeling scale, built for people, not for pristine lab conditions. It's all about whether you're reaching for a sweater or a swimsuit, making it surprisingly practical for just checking the daily forecast and getting on with your day. Now, let us hop across the pond to the system used by pretty much the rest of the world. If Fahrenheit is the folksy human-centric scale, Celsius is its clean, logical, and scientific cousin. Officially part of the International System of Units, Celsius is the metric of temperature, and its beauty lies in its elegant simplicity. It's built entirely around the physical properties of water, one of the most essential substances on our planet. As laid out by the Bureau International des Poids, et Mesures, water freezes at a neat and tidy 0 degrees Celsius and boils at an equally satisfying 100 degrees Celsius, at least at standard sea level pressure. This makes it a dream for science and everyday applications alike. There's no guesswork, no weird numbers, just a straightforward scale based on a universal constant of nature. While most of the world relies on Celsius for everything from baking a cake to conducting a chemistry experiment, there's another scale that takes this scientific precision to a whole new level, one that speaks the true language of the cosmos. Enter the Kelvin scale. This isn't your everyday weather report scale. This is the real deal, the language of the universe. Kelvin starts at the most extreme cold imaginable, absolute 0. This is the theoretical point where all molecular motion just stops. Imagine zooming in on the atoms and molecules that make up everything around us. They're constantly vibrating, jiggling, and dancing with energy. But as you get colder and colder, that dance slows down. At 0 Kelvin, everything grinds to a complete halt, a state of perfect stillness. It's the ultimate floor for temperature, a point from which all heat energy is measured. At Facts Discoveries, we don't think of Kelvin as a scale for weather, but as a scale of energy. Because it starts at absolute 0 and has no negative numbers, it is absolutely essential for the math used in thermodynamics and astrophysics. According to NASA, scientists use Kelvin because it directly relates temperature to energy, making their complex equations work without the headache of dealing with negative values. Ever notice how these scales sometimes line up in weirdly satisfying ways? You can actually experiment with these systems and see how they overlap. For instance, there's a single magical point on the thermometer where Celsius and Fahrenheit tell the same story. -40 degrees at this intensely cold temperature. -40 degrees Celsius is exactly the same as -40 degrees Fahrenheit. It's the unique crossover point where these two different languages find common ground. It's a cool piece of trivia, but it also highlights just how different their increments, or degrees, really are. Each step on the Fahrenheit scale is smaller than a step on the Celsius scale, which is why the numbers diverge so quickly above and below that -40 mark. So, when a scientist is talking about the mind-boggling temperature of a distant sun or the chilling reality of a liquid nitrogen experiment, you can bet they're not using Fahrenheit. They are almost certainly using Kelvin. Why? Because in high-stakes science, precision is everything. When you're calculating the energy output of a star or the behavior of matter at near absolute 0, Using a scale with negative numbers like Celsius or Fahrenheit can throw a wrench in the works. Kelvin, with its absolute zero starting point, ensures that all the mathematical relationships between temperature, pressure, and volume remain straightforward and pure. It's the gold standard for scientific measurement, the bedrock upon which much of our understanding of the universe is built. You can even see these different signals of heat playing out right in your own kitchen. Take a look at your oven dial. It's probably set to something like 350 degrees Fahrenheit for baking cookies. That number is perfectly tailored for our common cooking experience, but a chemist or a food scientist would see that same heat through a different lens. To them, that oven is humming along at roughly 177 degrees Celsius. And to a physicist, they'd measure that same energy level as about 450 Kelvin. It's the same amount of heat, the same dancing molecules, just described in 3 different languages. Each one is useful, each one is correct, but each one tells a slightly different part of the story. The shift from Fahrenheit to Celsius in many countries, like the UK, Canada, and Australia, during the 20th century, wasn't just a casual change. It was a massive nationwide effort in metrification. The goal was to align with the rest of the world to streamline global trade, scientific communication, and international collaboration. Imagine the confusion if airplane pilots from different countries were using different units for altitude, or if scientists couldn't easily replicate experiments because their temperature readings were in a different format. Adopting the metric system, including Celsius, was a huge step toward creating a more interconnected and efficient global community, ensuring everyone was quite literally on the same page. Ultimately, understanding these 3 systems, Fahrenheit, Celsius, and Kelvin, is like becoming fluent in multiple languages. It allows us to bridge the gaps between our own daily sensations, our global community, and the fundamental laws of physics that govern the stars. Fahrenheit speaks to our personal comfort, Celsius speaks the language of our planet's water, and Kelvin speaks the language of universal energy. Each one gives us a unique perspective, a different tool for making sense of the world, from the weather outside our window to the fiery heart of a galaxy millions of light years away. So, the next time you glance at your phone for the temperature, take a second to think beyond the number. Try to visualize the invisible world of molecules all around you. Are they dancing at a lazy 72-degree Fahrenheit pace, perfect for a picnic? Are they simmering near the 100-degree Celsius boiling point, or are they buzzing with a fiery 295-degree Kelvin energy level? It's the same reality, just seen through 3 different fascinating lenses.